I wanted to review calculating the interest on a note by calculating the future value and then doing it again, assuming semi-annual compounding. So the first time we're going to do it, we're going to assume annual compounding, and the second time we're going to do it, we're going to assume semi-annual compounding. So for annual compounding, for note 1, we're borrowing $20,000. So on day 1, we've got $20,000, and we're going to repay that $20,000 plus interest in the future. What will that be for note 1? In the future, with annual compounding, I'm going to have the present value times the table factor is going to give me that future value. Now, in this particular case, they didn't ask for the future value. They asked for the interest amount that was in the future value. So we'll get the future value, subtract out the present, and that will be the interest that grew on it. The difference between what it is now and what it will be later is the interest in a lump sum problem. Okay, so let's look for the factor here. 6 periods at 4%, so that's that first red box here. 1, 2, 6, 5, 3, 2. And so the future value of that 20,000 will be 20,000. Of course, this is the future value of the table because that's the unknown, things we're trying to solve for. I think we can round to dollars here safely. All right, so it grew, right? It looks to me like it grew 5,306. Let's do the next one. So the next one is 6% 4 periods. So that's that second red box. All right, and so the future value of that $20,000 loan would be the $20,000 plus the interest at 6% for 4 periods. And so that one's going to grow to $25,250. So the interest on that is the $5,250 because the $20,000 is just repaying the original loan. So the extra is the interest. All right, and then the factor for the 8% 3 periods is on that third red box. So we can calculate that, and we get 25,194. So 20,000 of that was the original loan. So that 5,194 is the interest that was added into it by having it bake at those interest rates for that many periods. Now, what if it was a semi-annual compounding? That means that at every 6 months, you take the interest for that 6 months and add it to the original loan and calculate interest on interest. Okay, so for semi-annual, that would cut the rate in half. So it would be 4%, but paid 2% and then 2%, 2% for the first 6 months. Then that adds to the 20,000. So the second 6 months is accruing interest on the 20,000 plus the first 6 months of interest. All right, so that's going to be half and twice as many periods, because now there's going to be 2 periods in a year and not 1. So it's still 4% annually, but compounded twice in a year. So twice as many payments and half the rate. All right, so now we have to move our little boxes here. Now we need 12 periods, 2%. So it's 2% and go down to 12 periods. And then our future value is now 25,365, a little higher because we're earning interest on interest as it compounds. So the interest portion is the 5,365, removing the original 20,000 that's not interest, but just repaying the original loan. All right, let's do note 2. So half the interest rate with twice as many periods. Okay, so let's go find that. Let's move this red box here. Now we want 3% 8 periods. Okay, 3% 8 periods. So now we need that table factor. And let's calculate the total amount due and the interest portion of that total amount. We repay the $20,000 plus $5,335 in interest. Note 3, if we're going to do semi-annual, it means each period is going to have half, but there would be twice as many periods, so the 3 times 2. All right, so let's move the red box now. That's going to be now 4%, and then 6 periods, so that's going to drop it right there. 1.26532. And let's see here. So now it's the 25,306 includes the 20,000. So the first 20,000 of that is just repaying the original loan. So 5,306 is the interest portion of what's due at maturity. Let me know if you have any questions.